Isotopes are different atoms of an element with the same number of protons and electrons, but a different number of neutrons within the nucleus. The example we're going to look at here is bromine. There are two isotopes of bromine. The first one is an isotope with an atomic mass of 78, and the second one is an atomic mass of 81. Now that you notice that the atomic number remains 35 for each of these bromine atoms, that's because the atomic number represents the number of protons within the nucleus and not the number of neutrons. Within a sample of bromine, the abundance of each of these isotopes are going to be different. So I'm going to give some percentages to these. So the first one I'm going to give 60%, and the second I'm going to give 40%. So what this means is that in a sample of bromine, 60% of the atoms within that bromine sample will be of this isotope, and 40% of the bromine atoms will be of this isotope here. Now we can calculate the relative atomic mass based on the abundance. Now the first thing that we do is we work out how much there is of each of these isotopes. So the first isotope, this one here, there is 60% of this isotope, and the atomic mass is 78. So 60 times 78. And we can add that to the percentage of the second isotope with the atomic mass of 81. Now we divide this by the whole, and the whole is the 60 plus the 40%. So we can write our 60% plus our 40%. So this equation is basically stating here that there are 60% of our atoms have an atomic mass of 78, and 40% of our atoms of bromine have an atomic mass of 81. And we're simply dividing that by the whole, which is 100%. Now the first step is to work out this calculation so far. So this is step number 1, and step number 2 is where we complete the first stage calculations. So 60 times 78 is 4,680, and we add this to 3,240, which is the 40 times 81, and we divide that by the 100. Now, first of all, what we're going to do is we're going to perform this little calculation here, and that equates to 7,920 divided by 100. Now, the answer to that question is therefore going to be, I'm just going to move that up a little bit so I can fit it on, is 79.20. Therefore, the answer to this question is the relative atomic mass of bromine is 79.2. So that is the answer to the question, and it is how you work out the relative atomic mass of an element based on the abundance of its isotopes.